In this video, I'm going to demonstrate the use of a utility that comes along with Microsoft Excel called Solver. What Solver does is it's used to solve or optimize various linear programming problems. In other words, determine the maximum value or the minimum value. I'm going to use the same two examples I used in class, and that we use, if you recall, we used the graphical method to solve it. Well, now I'm going to show you how you can use Solver to obtain the same results. Just as a recap, you recall that there was a manufacturing company called Ace Novelties, and they made two types of souvenirs. They made a Type A souvenir and a Type B souvenir. Type A souvenir generated $1 in profit for them. Type B generated $1.20 in profit. Type A took 2 minutes on machine 1 and 1 minute on machine 2. Type B took 1 minute on machine 1 and 3 minutes on machine 2. And if you recall, we were constrained by 6 hours of time available on machine 1, or that's 180 minutes. And we were constrained by there was 5 hours available on machine 2, or 300 minutes. Then we generated what we called an objective function. That's a function that defined how the objective, the profit, was to be computed. And it would be computed for the profit contribution of $1 times the number of units that they manufacture, plus $1.20 times the number of units of Type B that they manufacture. And of course, here were our inequalities that constrained our optimum solution. 2 minutes for each of Type A, plus 1 minute for each of Type Y, and we had to make sure it was less than 180 minutes, and 1 minute for Type A, and 3 minutes for Type Y on machine 2, and that had to stay under 300 minutes. Okay? So what I'm going to do, I'm going to transfer that data here onto the spreadsheet. So underneath Type A, I'm going to say it was $1 a profit for Type A and $1.20 for Type 2. Machine 1, it took 2 minutes on machine 1, and Type B took 1 minute on machine 1. On machine 2, Type A took 1 minute, and Type B took 3 minutes. We were constrained by 180 minutes. Whoops, wrong one. 180 minutes on that machine, and 300 minutes on that machine. Okay? Well, I'm going to modify this slightly to make it easy for me to find the inputs I want for Solver. Here's how I'm going to do it. I'm going to insert a row above the profit line, but underneath the headings that says Type A, Type B, and limits. Okay, I'm going to do that, and then I want to select 2 cells in there that I'm going to color yellow, because these are the cells that Solver is going to use and change. Pick an A, pick a B, and compute the profit and see if it's bigger than the previous one. So Solver is going to repeatedly change those values until it obtains the largest value it can. Okay? Then also I'm going to add 2 rows in between that part of the table and the last row. And I'm going to insert 2 rows. I want to shift the ones that are affected to the right, and there I have 2 additional rows. I'm going to slide that one down for a minute so it's a little thinner, so I think you will see. Okay? Then I also want to tell Solver, when I find the optimum combination of Type A and Type B, I want you to tell me what the profit is. And so this is what I'm going to call my target cell. That's where I want Excel to tell me what profit is. I'm going to color that green. That's an easy one to remember for money, is green. Okay. Now I want to tell Solver what my constraints are. And so in here, I'm going to give it the formula that it should use in order to determine how much of machine A was manufactured, or how much machine 1 was used to make that optimum solution. And that function is defined by the number of minutes it takes to manufacture that type times the number of that type plus the number of minutes to make that one times the number that he manufactured, and then add the two of them together. And so that will generate how many minutes, when I achieve the optimum solution, how many minutes of type A. I want to make sure that that is less than or equal to 180. I'm going to do the same thing for the next constraint. I'm going to tell Excel what the formula is to compute it, and that's the number of minutes for type A times the number of A's that were made plus the number of minutes of B times the number of B's that were made. Okay? Well, I think that too must be less than or equal to 300. Okay? So now I think I'm ready. I've got everything I need to call up Solver. To find Solver, I go to the Data tab that's there, and I look for a section called Analysis. And if you look in that analysis, there's my Solver. If you look on yours and it's not there, it's because it hasn't been added yet. And we will need to add Solver so we can use it. Well, let me show you how to do that if that's not there. Go to the File menu, and on the File menu, click on Options. Then it opens up the window, and on the left-hand side, there are a number of options that you can say. We're going to choose Add-ins. We click the Add-ins. It then gives us a list of those add-ins that are active and those that are not active. If we do not see Solver in this list, it will be on an inactive one. And if it is, go down and press Go, and make sure that you click the one that says Solver Add-in. And it will then be added to your window, and after a couple seconds you will see it appear there. Okay? So we click on Solver. We click on Solver, and we want to tell Solver that the objective function, the target, where do you want me to put the answer when I'm done? And I want him to put it in D4. Okay? I want to find the maximum value. You see, I can either do maximum, minimum, or I can specify a value I want it to achieve. Okay? Solver is going to do that by changing cells. And the cells that are going to be changed is the ones I added. So I've told it cells B3 and C3 are the ones I want to change. And now I want to tell them what the constraints are. Okay? So I click on the constraints, and it's asking what is the cell reference that Excel should use to compute the total number of minutes on machine A. That's why we created D5. We want to make sure it says less than or equal to. If it was different, then we would click that down arrow, select the correct one. Okay? And then the limit or the constraint is 180. Okay? If we click the Add, it will place it on the list. And now we're going to add another one. It's now asking for another constraint. That's that one there. Less than that one there. And that's, oops. That's, get ahead of myself. This is the cell reference there. And this is the constraint that's going to be compared to. So whatever number he finds there is going to have to be less than the number he finds there. Okay? If that's the last one I did, Now, if I had a full list of constraints, I could do the same thing over and over again until they're all there, and then click OK. And now you can see there's my objective cell, there's my changing cell, and there are my constraints. Okay. We want to make sure that the number of Suva made are always positive. So I want to make sure that's clicked there. That's where we said that x was greater than 0 and y was greater than 0. We also want to check the method that's solving. Well, here it says simplex, which is what we want, but there are some other ones that in other courses you take, you may end up using those. We're going to use the simplex method. Okay? So I think we've got everything done, so we're now going to click solve. Oh, it told us the objective cell must contain a formula. So what's my objective cell? D4. I never put the formula in there, did I? It's going to tell me. So in that cell, I'm going to close this off. In that cell, I want to put the formula for the profit. And if you remember, the formula for the profit is the $1 for that one times the number that it made plus $1.20 times the number of that type that it made. And that will be my profit. Now, solver should be happy. My objective is that. The changing ones are the same, and the constraints are the same. It's simplex, and it says non-constrained variables are non-negative. When I click solve, solver will tell me if he found a solution. And here it says, solver found a solution. All constraints and optimality conditions have been satisfied. You may want to say keep solver solution if it isn't checked, but usually by default it is. Okay, if you say OK, now look at what it's placed in there. Okay, it placed 48, wanted to make 48A and 48B, and it made $149. But I think if you recall, it was a number, and it was, since it was a number, we want dollars and cents. So we make sure it doesn't and force it to round it. And there's $148.80 is my profit. And if you check in the presentation in the book, or in my presentation in class, you'll find that that agrees with that. This ends part 1.